This is questions 1, 5, 12 and 15 from exercise 1.4 in New Concise Project Maths 3B. We have to express the questions in the form a plus bi, where a and b are elements of R, meaning they are real numbers, and I squared is equal to minus 1. So we just have to multiply out these brackets. So we're going to start off with question 1 where we have 2i times 3 minus 2i. So 2i times 3 is just going to be 6i. And 2i times minus 2i is going to be minus 4i squared. Now the question at the top here gives us a hint on this. It says that I squared is equal to minus 1. So what we get next is 6i minus 4 times minus 1, which is going to give us 6i plus 4, or to write it in the form that they asked us to, that is 4 plus 6i, like that. So that's question 1. In question 5, we've got 2 times 3 minus I plus I times 4 plus 5i. So let's just multiply that out. So 2 times 3 is 6. 2 times minus I is minus 2i. I times 4 is plus 4i. And I times 5i is going to be plus 5i squared, like that. So we're just going to tidy all that up. We're going to get 6 plus 5. Now I squared is minus 1, so it's 5 times minus 1. And then minus 2i plus 4i is going to be plus 2i, which means we have 6 minus 5 plus 2i. So we get 1 plus 2i, like that. And that's question 5. Let's take a look at 15. In this case, we've got brackets to expand out. Now we can do this the long way out, and that's how I'm going to do this. But if you were looking carefully, you might have spotted that this looks like a factorization of a difference of two squares. And I will make a note of that at the bottom as to how that could be done. So if we just multiply everything in the bracket on the left by everything in the bracket on the right, so we got 2 by 2 is 4, and 2 by minus 3i is minus 6i, and then 3 by 2i is plus 6i, and then 3i by minus 3i is going to be minus 9i squared, like that. Well, minus 6i plus 6i is 0, so we're just going to get 4 minus 9 times, and then I squared is equal to minus 1. So we just get 4 plus 9, which is equal to 13. But they wanted this in the form of a plus bi. So this is going to be equal to 13 plus 0i, like that. Now the other way that we could have done this is if we remember our factorizing difference of two squares, where we have a squared minus b squared, and that can be factorized to be a minus b times a plus b. That's exactly what we have up here, just going the other way. So we would have, so from our very first line in question 12, we could go straight to 2 squared minus 3i all squared. So that's going to be 2 squared minus 9i squared. So it's going to be 4 minus 9 times minus 1. So 4 plus 9, and we get 13. So we get to the same place in the end, no matter which way we go, but that's another way of doing it. And then if we take a look at question 15, if we can see just above question 15 here, we can expand a plus b squared as a squared plus 2ab plus b squared. So applying that reasoning to this, where instead of a we have 5 and instead of b we have 2i, we're going to get 5 squared plus 2 times 5 times 2i plus 2i all squared. So we're going to get 25 plus, and then 2 by 5 is 10, 10 by 2 is 20, so 25 plus 20i plus 4i squared, but don't forget I squared is equal to minus 1. So we get 25 plus 20i plus 4 times minus 1. So we're going to have 25 minus 4 plus 20i. So it's going to get 21 plus 20i, like that. And that is that.